Alright, so we're going to finish on 632, in the last of your angle formulas. These are called the half angle formulas. They can be derived from the double angle formulas. I'm not going to go over the derivation here. I'll just give them to you and then we'll apply it. A couple different ways to write this. Sine of alpha over 2 they're strikingly similar. Different way to write it with cosine. Kind of a more complex form. Okay, so we'll go ahead and apply this to a question. Hopefully, it's write pretty small because it's going to take up most of the space. If cosine of x equals -4/5, and x is an element of in the interval pi to 3 pi over 2, think domain, I'm going to find three things. So this is like your domain. Pi to 3 pi over 2 means we're in quadrant 3, and -4/5, that is not on the unit circle. So we need to draw a triangle in quadrant 3. Draw a triangle in there. We're using x to represent theta. And it's cosine, so adjacent over hypotenuse, so we get -4/5. Now, you could use the Pythagorean theorem, or you can notice that this is Pythagorean triple, so this side's going to be 3, and it's actually -3 because you're going down. That gives me my three sides. And I'm going to ask you to find a couple different things here. The first is sine of 2x. Now you can't find sine of 2x unless you expand it to this form using your double angle. Now you know those two are equivalent because of the double angle formula. And this makes our lives easier because we know what both sine and cosine are. Sine is -3/5. And cosine is -4/5. So now when we multiply these together, 24/25. Same thing here for b. Now we're going to look at cosine of 2x. Now we can use whatever formulas we want here. We have three of them. I'm going to use the first one, cosine squared x minus sine squared x, because we have those values. And you could use the other two if you wanted. You get the same answer. That's the cool part about it. -3/5, -4/5 squared minus -3/5 squared. We move this up, we get 16/25 minus 9/25, which gets us 7/25. So that's the sum for cosine. Now on the next page, we're going to look at two others, the half angles. So C is sine of x over 2. Then we're going to use our half angle formula. This is all really like algebra on steroids here. So we're evaluating again. We know that cosine is -4/5, so it's 1 minus -4/5 all over 2. And this just becomes kind of like crazy algebra. So we can write 1 as 5/5. It's the same as the number 1. Minus -4/5, all divided by 2. Which would give us, continue on this, 9/5 divided by 2. And this form, like how we grew a little bit bigger there, we can rewrite this as 9/5 times its reciprocal, which is 1/2, which equals radical 9/10. Take this farther, and we get 3 over rad 10. Problem with that, we've got to rationalize the denominator, rad 10 over 10. So we end up with a final answer here, at least of 3 rad 10 over 10. Problem is, if we go back to the beginning, we have a plus or minus. Now, we're dealing with sine, so if we think of sine, and we're in quadrant 3, sine is negative in quadrant 3. So, my answer is not positive and negative, it's just negative. We'll finish up with D. This is 109, by the way. You probably recognize it. D is cosine of x over 2. Same process, plus or minus 1 minus 1 plus cosine of x over 2, which will equal 1 plus negative 4 over 5, 2, same process again, 5 over 5, minus 4 over 5 over 2, which equals, I'm getting tired just doing this, 1 over 5 over 2, 1 over 5 times 1/2, which equals square root of 1 over 10, 1 over rad 10, multiply by rad 10 over 10, and we end up getting rad 10 over 10. Now we need to think positive or negative. Again, we're in quadrant 3. Cosine is negative. Tangent's the only thing that's positive there, so it's negative. Final answer, negative rad 10 over 10. So now you see us using the double or the half angle here. In the previous, A and B, we're using double angle. Okay, I know these are kind of more algebra on steroids versus anything, but if you can't derive the formulas, you'll have trouble there. Hope this helps.